Hello everyone, this is Zodus. This is the beginning of my channel that is mainly going to be focused on Minecraft, but soon to come we'll have Let's Plays and stuff like that, but as of right now I'm going to do a kind of beginner's tutorial playlist for, Redstone. So basically, I'm going to teach you the basic concepts of redstone circuitry, the different types of logic gates to create different circuits, and then eventually I will do like simple tutorials on simple types of things you can do with redstone, and then I'll get into more advanced things as well. So you can watch through the things, because I know redstone is frustrating for a lot of people, but once you actually start learning to use it, it's really fun, really neat, all the stuff that you can make. But this is just, I'll get to this later. I just kind of put it there so I don't have to build it, in the middle of this. But oops, let's see here. Let's start. Basically, redstone is as I'm sure everybody knows. I mean, even if you don't use it, you would know that it's what is used to build circuits. It carries electrical current from main power sources, i.e., pressure plates, levers, buttons, things like that, redstone torches. And there are three main bits of redstone circuitry. There's also pistons which come into play, and there's also different things you can use, but the main power sources are carriers of current. We got your dust, your repeaters, and your torches. The redstone, when it's activated by a power source, for example, stepping on a pressure plate, the redstone can only carry current 15 blocks, so you would use repeaters to boost the strength of that. And the way it kind of works is that let's see here, give you an example. We have, say, a lever. You lay the repeater in the direction that you're trying to face. This is one thing that people mess up when they're trying to do circuits. Repeaters, the arrow has to be pointing in the way that you want your current to be flowing. So basically, they also work as kind of like a double feature, where if you put them this way, it's going to stop the flow of current. So from your source, if I were to turn this on, see how the other end of redstone isn't working. But if I were to go out towards the end here, where the current is less strong, you'll be able to see a difference in how it boosts the signal of the redstone. It's kind of dimmer here, and then it re-brightens. But at about 15 blocks, the glow is almost is like 0. So you can tell even further. But I like to space mine like 5 or 6, just because I like to be certain, because I don't really like to count blocks anyways. So we got that. Now this involves the concept of powered blocks. Concept of powered blocks is that it's not like per se a block itself. It's more like an area of space that is powered. It's there, but it's not. So, say for example, oops, place a torch here. This is the block that is containing the torch right here, but this is the block directly above it. The block directly above a torch would be the air, and adjacent to it would be, air out from where it's located, because this is technically where it's contained, the actual power source. It's kind of confusing. Kind of just don't worry about the theories of it, I suppose. So to transmit power, a block has to be an active source, and by transmitting I mean accepting a current and then transmitting it outwards from it. So to transmit, it has to be an active power source, and active power sources are redstone torches. Repeaters act as active power sources. Let's see, redstone wiring, or look, the switch is technically the active power source, but the wiring coming off from the switch is an active power source. And blocks above redstone torches are active power sources. That means if you put a block above a redstone torch, shorted out that current, I'll get to that later. You put a block above it, it's going to power if it's on, but it's shorted it out, so I gotta reset it. put a block above the redstone torch, it is going to power the wire on top, meaning that it is an active power source. It transmits power. And then we have an active power conductor, or whatever they want to call it, I suppose, people with the technicalities, which would be wiring, active redstone wiring, mind you, running into into a block of some sort. Won't transmit this way, but it'll transmit through torches. See how it turns the torches off. That's what I'm getting to next. So torches, they power the block directly above them and all 4 adjacent blocks to them. So that would mean this one, this one, this one, this one, and the one directly above it. Or in this case, when it's on a block, it would only be the 3 directly beside it. This is the space that it's in, remember? So it's going to power any type of wire right here, and wire right here. I'll show you by turning this off and inverting the signal. See that? And then I just showed you it'll invert this as well on top. So let's see, the pressure plates. This is what I was getting to. The pressure plates, technically, when you step on them, they activate the block that contains them, which would be this block. And so if you were to put, well, the block containing them is the one above this, mind you, as well as containing the block that it's on top of. But so when you step on it, it's going to power things directly adjacent to it, but it also powers one block beneath the block that it's resting on, as I showed you here, where I laid down that, and then I stepped on this, and it turns that on. So that's good to know. The levers and buttons, I'm sure you know that the lever is permanent, and then the button is just a short signal. When it pops out, the signal goes away. It's the same thing as a pressure plate. But you can do it this way as well, because torches and buttons the same will power this block. They power the block that they are directly on, as well as the block behind them, the block of space. And seeing as where this gap is the block of space directly behind them, technically. If you run redstone wire in, it is taking up that space. See how the lines around it kind of come up? That means it's in that space. So when you power this torch, or when you flip the switch, it's going to power that. And it works the same with buttons as well. Some things that people get wrong that generally really make them mad when they're trying to build circuits and they don't really know exactly what they're doing is that people think, how can I show this to you? How can I do it like that? People, no, I can do it like well, people think that if you put a pressure plate down on top of a torch and you step on the plate, it's going to power the torch off, but it doesn't. That's a common misconception, so don't do that. It can only power wire. Just as I'm fairly certain, I never really try it, but I'm fairly certain, yeah, that works. Remember that it does apply for levers, though. Levers and buttons can power off torches, but they can only power off torches when they're directly connected to the block containing the lever. So if you put a torch here, not going to do anything. It has to be connected. You could also put the torch there or there. Doesn't matter. Okay, so what else for the basic concepts? I mean, I suppose that's really it. There's a couple things for when you're doing wiring that people also mess up and don't really notice, and then don't notice when they're trying to debug their circuit. Is that say you got a couple logic gates are going to have multiple levels, and then you're going to have redstone like down here or whatever, and then you're going to have to like line something up to come up to the next level, and you're going to place it there. Just know that this connects, and if you're using a logic gate that requires opposite inputs, signals on the inputs to give you a certain output, what you can do to cancel this is just set a block on top of either one, really. You can set it on the side by like getting it like that, or you can just set it directly on top and it cuts out the signal. So that's one of the things you got to be wary of. But if you were to go like this, you could also do it this way, where you put a repeater next to where it's touching and it cancels that out. The repeater will only send the signal this way, and you can go about your business. So, also remember, there is a way to get around this whole concept of, let's see, most people say, well, let's see, if you put, say you're doing a lever here, you know, and you want it to be raised up like that, so you have to have redstone coming off, but instead of it connecting like this, you want the signal to invert, so when it's off, that means it's off, like, or in the down position it's off, and it's on in the up position, and you want to invert it like that, but you also need to add something on top. If you put a block on there, it's the same concept. It's going to cut out the redstone and the torch, because in order for this block to be an active transmitter, it has to have the redstone on top, but you also, the redstone on top is directly powering that torch, so you got to remember that. You can't cut off signals, or else you'll completely short out the thing. You'll just short out everything. Okay, so I think that's about the basics. So this is just the opening intro for people that don't know anything at all, or kind of don't know anything at all. Next in the series, I'll be covering different types of logic gates. I'll give you demonstrations on what the logic gates are and how you can use them in combinations with other ones once I go through all of them. Okay, well, yeah, that concludes this part. I'll have a link in the link in the description, and I'll put an annotation here for you so you can check out the next bit if you like.